say one can derive the equation of any physical quantity in terms of some other physical quantities. Here that application is given to you as an example. Okay. Now see the next example. Example 2.17. Consider a simple pendulum having a bob attached to a string that oscillates under the action of the force of gravity. Suppose that the period capital T of oscillation of the simple pendulum depends on its length L, mass of the bob m, and acceleration due to gravity g. Derive the expression for its time period using method of dimensions. Here, the physical quantity for which you have to derive the equation that will be given to you, and that particular physical quantity for which you have to derive the equation depends on which physical quantities that will be also given to you. જો આપણા example માં we want to derive the equation for the period capital T for the oscillations of simple pendulum. Now period for the oscillation of simple pendulum depends on which physical quantities that is also given to you. It may depend on length of the pendulum, mass of the bob attached in the pendulum, and acceleration due to gravity. Clear to all of you question? Now let's start. See, here it is given to you the period of the oscillation of simple pendulum that depends on length of the pendulum, gravitational acceleration, and mass of the bob. But in which manner it depends, that we have to find. એ કઈ રીતે ડિપેન્ડ થાય છે એ જો ખબર હોય તો પછી સીધું ઇક્વેશન જ બની જાય ને આપણાથી. But that we have to find. So here we have to suppose like this. Suppose period capital T proportional to length raised to x, gravitational acceleration g raised to y, and mass raised to z. So we can rewrite this equation as T equal to K, that is the proportionality constant, which is dimensionless, into L raised to x, g raised to y, m raised to z. K, that is dimensionless proportionality constant. Now here, compare the dimensions on both the sides. So left hand side, that is periodic time. So after all it is time. So m0, L0, T1. K, that is dimensionless proportionality constant. So no need to write its dimensions. And if you want to write, then you can write m0, L0, T0. But it is meaningless. No need to write. Then for length, dimensions, that is L raised to 1. And here L raised to x is appearing. So L raised to 1 raised to x. Then g, the gravitational acceleration raised to y. So dimensions of g, that is L1 t raised to -2 whole raised to y. Then for mass, m raised to 1 and this whole raised to z. Now simplify the right hand side. Left hand side, that is as it is m0, L0, T1. Here right hand side, L raised to 1 raised to x, power 2 power multiplication will be there. So L raised to x. L raised to 1 raised to y, so L raised to y. T raised to -2 raised to y, so T raised to -2y. M raised to 1 raised to z, so M raised to z. Now we can rewrite this equation as left hand side as it is m0, L0, T0. On right hand side, m raised to z. So first write m raised to z. Then L. So L raised to x into L raised to y. So resultantly you can write L raised to x plus y. Then t raised to minus 2y. Now for correct equation, both the side the dimensions should be same one. So here, to derive the correct equation, we have to consider the same dimensions on both the side. So we can compare now the powers of MLT on both the side. So m raised to z, m raised to 0. So we can write z equal to 0. Then L raised to x plus y, L raised to 0. So x plus y, that is equal to 0. T raised to minus 2y, t raised to 1. So minus 2y equal to 1. So y equal to minus 1 by 2. And in this equation, x plus y equal to 0, substitute y equal to minus 1 by 2, you will get x equal to 1 by 2. Means now these unknown powers x, y, z are calculated. X comes to 1 by 2, y comes to minus 1 by 2, and z comes to 0. And anything raised to 0, that is 1. So here when we substitute the values of x, y, z, then periodic time t equal to k L raised to x, so that is 1 by 2. G raised to y, that is minus 1 by 2. M raised to z, z that is 0, so m raised to 0. Anything raised to 0, that is 1. And see here, actually the periodic time that does not depends on the mass of the pendulum. So here automatically mass is discarded. So now we can rewrite this one as t equal to k L raised to 1 by 2, g raised to minus 1 by 2. So we can rewrite k L raised to 1 by 2 upon g raised to 1 by 2. So k into L by g whole raised to 1 by 2. So we can write t that is equal to k under root L by g. તમે આ equation ને આ રીતે પણ રાખી શકો. This dimensionless proportionality constant that will be given to you. And if you know about it, then also you can substitute the value directly. Actually, this type of dimensionless proportionality constant which appears in the equation are calculated separately by some other methods. So don't worry about it at present. Now at present we know here this dimensionless proportionality constant, that is 2 pi. So finally we can write the equation for the period of simple pendulum, that is t equal to 2 pi root L by g. Clear to all of you?